Last week we were talking about finding the zeros using those theorems and everything. What is a zero? It's an x-intercept. So just as a reminder, our zeros are our x-intercepts. So it's some number x when y is 0. It's where our graph crosses the x-axis. Good. So a polynomial equation is a polynomial that has been set equal to 0, such that f of x equals 0. So when we set y equal to 0, that's when we're finding the roots, the solutions, the x-intercepts, the zeros. The zeros are the solutions. So another name for zero is solution. Again, it's when it's what value of x when we set f of x equal to 0. So what is x when y is 0? And again, they're also called the x-intercepts. All right, so they give us this polynomial equation that's already factored, just to kind of review of like how do we find a zero. So remember, we would set each factor equal to 0. So we would set x plus 2 equal to 0, x plus 2 equal to 0, x minus 5 equal to 0. And each time we would solve for x to see what our x-intercept is. So for the first one, we would subtract the 2 and get negative 2. The second one, we would also subtract the 2, get negative 2. And the last one, we would have to add the 5 and get positive 5. Shortcut is, it's just the opposite sign of whatever's in the parentheses, but that's kind of where that comes from. So for this one, we have two different zeros, right? Negative 2 happens twice, and usually we don't write it twice. So in this case, we have negative 2 and 5 as our zeros. And you don't have to put those brackets around it. That's just how this is. You can just write negative 2 and the 5. So something that we haven't talked about yet, that's kind of like the only new thing we're doing today, is called the multiplicity. So the multiplicity of a zero is how many times that zero occurs in a specific polynomial. So like for this one, we had x equals 5. That happened one time. How many times did we get negative 2? Twice, 2 times. So we would say that negative 2, so x equals negative 2, has a multiplicity, and I'm going to just abbreviate MULT, has a multiplicity of 2. So instead of, because normally we have been just writing it one time, we're now going to introduce this idea of multiplicity and how many times does it occur. All right, so we're going to divide this polynomial by x minus 3 using our synthetic division, and we're going to try to see if this is a zero. So last week we did our synthetic division, divided, got a new polynomial, and then kept factoring to find all of our zeros. So we're going to do the same thing. Now, if I'm dividing by x minus 3, what number is going to go on the ledge? Positive 3. Right? We would take that x minus 3. Sorry, my pen will let me write. X minus 3 equals 0. And we would solve for x, so we would get positive 3. That's how we get the number on the ledge. So we get positive 3 on our ledge. And then we use the coefficients of our polynomial. So 1, negative 8, 21, negative 18. Now when I do the synthetic division, If 3 is a root of this polynomial, should I get a remainder? No, yeah, we saw last week that if we don't get a remainder, that means that it is a 0 of the function. So I'm looking to see if I get a remainder or not. So I'm going to bring down my 1, multiply 1 by 3, add, we get -5, multiply again, -15, add the columns, you get 6, multiply again, get 18, add the columns, you get 0. So we have no remainder, so this would be a 0 of this polynomial. So we want to completely factor this. If I start with an x cubed, what is my new polynomial going to start with? X squared. So there'll be a 1 in front of the x squared, so it'll be x squared. And then there'll be a -5 in front of the x, so it'll be -5x, and then we have a +6 on the end. And we're trying to completely factor this, so I don't want to leave out my x minus 3 that they already gave me. So I still have that x minus 3 parentheses that they gave me in the initial problem. So I got a quadratic. There's no number in front of the x squared, so we could factor like normal. So I could think of 2 numbers that multiply to be 6 and add to be -5. Grayson. -6 times 1 would give me -6, so I'm looking for a +6. McKenna? -3, -2. Yeah. Alright, so it would be x minus 2, x minus 3, and x minus 3 on the end. So this is our completely factor polynomial, and now we want to find the zeros. So if we start with an x cubed, how many zeros do I need? 3. Yeah, we talked about this idea of like whatever degree polynomial we have, that's how many zeros we should have for that polynomial. So we should have 3. The x minus 2 will give me what as a 0? +2. And then the x minus 3 happens twice, so that'll give me a +3. Right, opposite sign is +3. What's the multiplicity of that +3? 2. It happens twice, so we have 3 with a multiplicity of 2. And so because that 3 happens twice, like that gives us our third 0. So we have 3 zeros, it's just one of them happens twice. All right, questions so far? All right. All right, so for my next one, they want me to use synthetic division to determine if -5 is a 0. So when we're trying to determine if something is a 0, and I'm using synthetic division, what am I looking for? I'm doing -5. No remainder. So if we put -5 on the ledge and do our synthetic division, if we don't have a remainder, that means it is a 0. If there is a remainder, that means it's not a 0. All right, so I'm going to do 1, -5, -1, +5. So bring down your 1. 1 times -5 is -5. Add, we get -10. -10 times -5 is +50. Add, we get 49. 49 times -5 is -245. Add, we get -240. So I have a remainder. Does that mean that -5 is or isn't a 0? It's not. So there is a remainder. So that means -5 is not a 0. So for the next part, they tell us that this 0, -1, is a 0, and then they want us to find all of the other zeros. So if -1 is a 0, when I do my synthetic division, what am I looking for? No remainder, yeah, remainder of 0. So we're going to plug in -1. We'll have 1, -5, -1, and 5. Bring down your 1, multiply 1 by -1, we get -1. Add, we get -6. -6 times -1 is +6. Add, we get 5. Multiply again, we get -5. Add, we get 0. So we did get a 0 remainder, so we're good. We're going to write our new polynomial. If I start with an x cubed, what is my new polynomial going to start with? X squared. So it'll be 1x squared, -6x, and then plus 5. Now, my problem started with an x cubed. They already gave me one of the zeros, so how many zeros do I need still? 2. We need a total of 3 zeros. They gave me one of them, so I'm looking for 2 more. So we're going to factor this quadratic. We want 2 numbers that multiply to be 5 and add to be -6. Kenna? -5 and -1? Yeah, I agree. So it'll be x minus 5, x minus 1. All right, so what are my 2 other zeros for this one? +5, +1. All right, so for both of these, we're going to factor and find all of the zeros. So for the first one, what do I notice about the first one? X cubed minus 4x squared plus 4x. Grayson. There's no constant. So what does that mean is automatically a 0? 0. So last week we talked about this idea of like if there's no constant term, that means that 0 is always a 0 of that polynomial. And you could see that they don't give us a 0 to work with for that one. So you can either put 0 on the ledge and do your synthetic division, or we could do what? We can factor how? We can take out a GCF first. So if from x cubed, x squared, and x, I can plot an x and make this x squared minus 4x plus 4. Because this x in the front, that gets me that 0, that's 0. Now if you did your synthetic division with 0, you should be able to get down to this quadratic right here and then factor. So either way, you're going to get the same answer. We can factor like normal. We want 2 numbers that multiply to be 4 and add to be -4. -2, -2. Good. So we got x minus 2, x minus 2. All right, so we want how many zeros for our answer? How many zeros does this one have? Should have 3 because we got an x cubed. All right. What does the x in the front get me? Just the 0. And then I have x minus 2 twice. So that means positive 2 happens how many times? Twice. So it has a multiplicity of 2. So that 2 that happens twice gives me my third 0. Alright, so for the next one, they give us that 2 is a 0, so we could go ahead and do our synthetic division and try to get a new polynomial. So I'm going to put 2 on the ledge. Again, if I know that 2 is a 0, should I get a remainder? No. Alright, so we're going to write our coefficients. So we have 1. What should come next? Why 0? Because there's no x to the 4th term. Good. Some of you guys were forgetting that on your quiz. So remember, if you're missing any x to the whatever power, you got to put a 0 as a placeholder. So then we would put the negative 7. If my pen will let me write. Negative 7. And then the 6. And then I do need a 0 for my x, and I need a 0 for my constant as well. Alright, so we bring down the 1. 1 times 2 is 2. Add, we get 2. 2 times 2 is 4. Add, we get negative 3. Negative 3 times 2 is negative 6. Add, you get 0. 0 times 2 is 0. Add, you get 0. 0 times 2 is 0 again. Add, you get 0. So we did get a remainder of 0. So we're good. So now we're going to write our new polynomial. If my original polynomial started with an x fifth, what's my new one going to start with? X to the 4th power. So there will be a 1 in front of my x to the 4th. Trying to write. There will be a 1. Oh no, my pen's freaking out. Whatever. X to the 4th. And then it'll be a 2 in front of the x cubed. And then a negative 3 in front of the x squared. Alright, so that's part of it. I'm trying to factor this whole thing, so I'm going to put this 2 in a parentheses. If 2 is a 0, what is it in the parentheses? X minus 2. Remember, it's always the opposite sign. We always subtract our zeros. So I'm trying to factor all the way. Now, right now, I don't really know how to factor x to the 4th plus 2x cubed minus 3x squared. But what's our first step when we're factoring? GCF. Could I pull out a GCF from that part? Yeah, what can I pull out from? Yeah, we can pull out an x squared. So we're pulling out an x squared. So this will make this x squared plus 2x minus 3. So now that's a normal quadratic that I can factor. I want two numbers that multiply to be negative 3 and add to be 2. Three and negative 1. Yeah, so we got x squared, we got x minus 3, or x plus 3, x minus 1, and x minus 2. So we're trying to find all 5 of these zeros, right? We have an x to the 5th, so we should have 5 zeros for our answer. I'm going to go up here so I have more room. So the x minus 2, from our original problem, we know that's going to give us positive 2 as a 0. So we get positive 2. X minus 1, that will give me what? Positive 1. And then x plus 3 will give me what? Negative 3. So now we have the x squared in the front. What is that x squared going to give us? What'd you say, Brandon? You said 0. So we could think of this x squared as like x times x. And remember, every time we have an x, that gives us a 0 of 0. So we have 2 zeros, so what does that mean about the multiplicity? It's 2. So we have 0 with a multiplicity of 2. So every time you have an x, that's going to give you a 0 of 0. Alright, so I want you to try these on your own. We're just proving that these are either zeros or not zeros. We're not actually going through and like finishing factoring or anything. Just do your synthetic division, and you want to just prove that it is a 0 or it's not a 0. Alright, so check your answers with mine. So you should have gotten 0 both times for the first part because those are zeros. We want to show that they are zeros by getting a remainder of 0. And then for 0, we want to show that it's not a 0 by getting a remainder. So if you got a remainder, that means it's not a 0. Alright, so for number 4, they want us to write a polynomial equation that has a 0 of multiplicity 3. So we're just going to kind of go backwards. They didn't tell us what number to use for our 0. What number do you guys want to use? 5? Alright, so we want to write a polynomial that has x equals 5, that has a multiplicity, whatever. I'm just going to abbreviate because I don't know how to spell. Multiplicity of 3. So if it's positive 5, what would it be in the parentheses? Yeah, so it'd be negative 5. We have y equals some x minus 5. And it happens 3 times, so we need 3 of those. And then just to rewrite it, like condense, we can rewrite that as a x minus 5 cubed. We're not actually going to flow this out, we're just going to leave it like that. Alright, so so for number 5, they want us to write a polynomial equation that has zero as a zero of multiplicity 2. So this time they do give us the number. They say that 0 is a 0 and it happens twice, right? It has a multiplicity of 2. Now, when we have 0 as a 0, how do we see it in our equation? It's just an x. Like, you can think about it as x minus 0, but we don't really need to write minus 0. So we think about this as just an x, and we have 2 of those. So we have an x and another x. So we could think of this as y equals x squared. So if we're thinking about the graph of this, what does the graph of y equals x squared look like? What's it look like? It's not an exponential. X squared is what type of function? Quadratic, so it's a U-shape. What's it called? Parabola. Where would the vertex of this parabola be? At 0. Right, this is the parent function of a parabola. It would look something like that. So we would cross the x-axis at 0. All right, so for number 6, they want us to find the zeros of this function. So we need a factor. Now, there's no constant term in this one, so what do I know is going to be a 0? 0. So you can do synthetic division, or we can plot a GCF from x cubed minus 9x. What can I pull out? We can pull out just an x. So we can pull out an x and make this x squared minus 9. Now, what pattern is x squared minus 9? What factoring pattern am I going to use to factor that? Difference of squares. Good. We're subtracting two things that we can square root nicely. So we could factor that into x minus 3, x plus 3. So remember, for this unit, when we're factoring, we're going to be using all those different factoring methods, like difference of squares, factoring by grouping, cloud method, normal factoring. So what are our zeros for this one? We should have 3 because we started with an x cubed. 0. Yeah, positive 3 and negative 3. Right. And then part B, C, and D is kind of just a review of that vocabulary we talked about last week. For the degree, that's just the high. We're not going to talk about the name of the degree yet, but what's just the highest degree in this polynomial? 3. So we would say this is a degree 3 polynomial. What's a leading term? In general, what's a leading term? It's the largest one. It might not always be the first one if it's not in standard form yet, but usually it is the first one. In this case, our largest one is the first one. So is that leading term positive or negative? Positive. Sure, that's your largest degree. Now we're going to classify by degree and the number of terms. So because it has a degree of 3, what's it called? Cubic. And then how many terms does this one have? 2, so it's called a binomial. So 2 terms gives us a binomial. All right. You know I had all that on here. Oops. skipping these graphing ones until tomorrow, but go to this question. All right, so we want to select all that apply. I'll go through the first one with you, and then I want you to do the rest. We want to see which ones have -1 as a 0. So we're going to do synthetic division for each one. And if it is a 0, what am I looking for? No remainder. So for the first one, I'm doing -1 on my ledge. And then we want our coefficients. So we got 1, -4, -5, and we need a 0 on the end because we're missing our constant term in that first polynomial. So don't forget your 0. Bring down your 1. 1 times -1 is -1. Add, we get -5. -5 times -1 is 5. Add, we get 0. 0 times 0. 0 times -1 is 0. Add, we get 0. So does that first one work? Yeah, we didn't get a remainder. So that first one would be a 0. Or sorry, that first one would, -1 would be a 0 of that first polynomial. All right, so I want you to go through the rest. So I want you to see 4 more synthetic divisions, figure out which ones -1 works for. All right, so you should have just gotten that second to last one as another one that works. All right, any questions on that one? I try to color code it so you can see which ones go with which.